Hi everyone, my name is Felipe Vieira and I'm part of the group Milan, and today we're going to show you a little bit of our steganography project on Matlab. To start, we will introduce our GUI and explain how it works. So we have the first GUI with two push buttons that will open other GUIs. Let's start by concealing images. Here in this button you can see here that we have an example of image that is a dog, and also we have the option to upload an image, and also we have the option to upload any other image. So I'm gonna use the example, I'm gonna show you guys the example of the dogs right here, and also you can load an image. I'm gonna load the same image, the dog, because I don't have another one, so it's the same thing. And right here you see the image that is going to be concealed inside the original image. So we have 10 images here as examples. So we have 10 examples of image here. So we have 10 examples of images here that you can choose which one you want to conceal inside the dog, and then so that you can choose. So right here you have this button. Where you can choose from 10 images that we have as examples here. 10 images that we have as examples here, and also you can load an image. So as you can see, we have here like 10 different images that you can choose. And let's load an image just for an example. And here in this part you're gonna choose the technique that you want to use to hide the image inside the dog. So I'm just gonna choose this one here and conceal the image. Right here you can see that the image is being concealed, and here you have the option to save the image that was embedded. So here you have the embedded image and you can save it. Let's save here. Right now let's take a look at our recover image part. Here I have a similar layout as the other part of the. Here you have a similar layout as in the other one, but the difference here is that you choose first the embedded image. So this is the image that we saved in the other part. So let's get the image embedded. It's the one that you just saved, and then we're gonna choose the technique that we use to conceal the image into. So you need to be sure, you need to choose the same technique that you use to conceal the image. So in this case it's going to be this one here. So you just press this button and you're going to recover the image. This is the image that we used in the other. And then you have the recovered image from the embedded image, and here you also have the option to save that image. Here you have a similar layout as in the other one, but the difference here is that you have the embedded image as an input and the recovered image as an output. So here you're gonna load the image that we just saved in the other part. There is the embedded image, and then you're gonna choose the technique that you used in the other part to conceal the image, and in this case it's gonna be this one right here. And now you just press this button and you're gonna have the recovered image right here. I just want to add one detail. I just want to add one detail about the loaded images. I just want to add one detail about when I just want to add one detail about our image. Let's see. The detail of when you upload images from your computer is that every time that you're gonna upload it, the program, the function will the detail that you have the detail that we have here when uploading an image. The detail we have here when uploading an image is that whenever you upload a random image, the GUI is going to resize that image to a 400 by 400 because this is the size of the example images that we have. So we choose to use this standard as our standard for our, so we decided to use this as a standard for our images so that it can be easier for us to manipulate the data So now I'm gonna press here and recover, and then we're gonna have the recovered image. It's recovering, and there you go. And right now we have the recovered image, and we also can save it as we save the other part. So that's it about the GUI.
Hello, my name is Edgar Roscoe, and I am a part of Team Milan. Our first custom function is the flatten function. What this function does is it takes images that are in grayscale and makes them into black and white pixel images. So, for example, the 10 hidden images for this project are predominantly black and white images, so they look black and white. However, they have grayscale in them because they're grayscale images. So what we do with this custom function is we make them nice and clear with black and white lines. And how we started this custom function was we defined our threshold to be 130, and we said that for every element in the matrix, if that certain element or that certain pixel is greater than our threshold, which is 130, we define it as a number 1. Otherwise, if it's less or equal to 130, we define it as a number 0. And we use this function for our further custom function, which is the expand function. Testing. Our next custom function is the expand custom function. What this custom function does is it takes the hidden images and converts them into three-dimensional images. The reason is because the hidden images are one-dimensional images, so they have 400 rows and 400 columns. However, they're only one layer, so they're only one dimension. And the normal image, or the dog image, is 3 dimensions. So the dog image, for example, is 400 by 400 by 3. So what we do here is we take the elements of the flatten matrix, and we create a matrix with all zeros. So we create a matrix of 400 rows, 400 columns, and 3 layers as you can see here, are 3 dimensions with all zeros. And we look at every element, and for every element in the flatten function or the flatten image, if it's a 1, we have it equal to 255, which is white. And if it's not a 1, well, it's a 0 since we have a 0 matrix. And if it's a 0, we have it be a black pixel. This creates a three-dimensional black and white image with black and white pixels.
My name is Daniel Reyes. I am part of Team Along.
Testing. So in order to embed hidden images into a main image, we use the least significant bit technique, also known as the LSB method. And in doing so, we created a custom function called least significant technique with the inputs of a base image, flatten function, color, and significant number, where the base image refers to the main image or the cover image, in this case, the dog image. Flatten function refers to the function that we created earlier. The color is a string of either red, green, blue, indicating a channel of the RGB. And then significant number refers to the specific bit number in a binary number. We then created a variable of the number of bits plus 1, which equals 9. We then created a loop of logical arrays where if the input of the color is red, it refers to the first layer. If the input is green, it refers to the second layer. If the input is neither of these, it refers to the third layer, or the blue layer. We then created another variable of the chosen layer of the base image, in this case the dog image. Since the dog image is a three-dimensional array, we created this variable to indicate either the first, second, or third layer. We then created a loop where the elements of the flattened image are manipulated. With this being said, the number of bits plus 1, which equals 9, minus the significant number, which we specified in the function, would equal the bit number and the binary number that you want. For example, if you wanted the first least significant number, you would indicate a 1, which would equal 9 minus 1, which would equal 8. With this said, it would refer to the 8th bit number in a binary number. If you wanted the second least significant number, you would indicate a 2, and it would be 9 minus 2, which would equal 7, indicating the 7th least significant. It would equal the 7th bit number in a binary number, which would be the second least significant number. So on and so forth. With this said, if the elements in the flattened image or the hidden image would equal 1, then the specified least significant number would be changed to a 1. If not, they would be changed to a 0. Since the least significant numbers carry very, very little information about the flattened image, it would change very little the color of that image. Therefore, it would help in embedding that image into a main image. With these modifications, they would create a modified layer, as we indicated with this variable. That variable would be put into the indicated layer of the dog image, and with that said, we would have a dog image embedded with a hidden image.